Hello and welcome to the 1.2 Atomic Structure and Periodic Table exam style question and answers. Now starting off, we have the question 1 from the 2017 higher pass paper. We were asked to fill in the table with the letters representing elements in the periodic table above. Now, two elements in the same group, obviously A and C. As you can see going down, that's fairly obvious that groups are arranged that those with similar properties are above and below each other. Element which has 12 protons in its nucleus, again that is C. Now as you see going across, you also have 1, 2, 3, 4, 5, 6 and so on and so forth until you get to 12 at C. The element with a full outer shell of electrons, B, which is be your group 0, which will be your noble gases. The element in group 2, period 2, is going to A again, as you know, going across the periodic table, starting at group 1 over here. Group 2 and period 2, period 1 with hydrogen helium, and then period 2 with your lithium and beryllium. And then the element with the electronic structure 284. So you see that D here, it's a period 3, as you know, there's 3 shells of electrons, and then 4, so it's going to be group 4. So you just go across. Yeah, that's a very straightforward question. Again, here we're given the electronic structures of 5 elements in the periodic table, and then asked to state which one is directly below the electronic structure here shown for I, which will be 3, as you can see. As you see, the same number of electrons in the outermost shell, which is 4, with 1 extra full shell of electrons. And to the left of helium in the periodic table will, of course, be hydrogen with just 1 electron. Just going to the left of the periodic table, the number of protons, and therefore the number of electrons in the outermost shell will decrease. Now, nitrogen has 2 stable isotopes, nitrogen 14 and nitrogen 15, and you're asked to describe how they are similar and how they differ to one another. Now, obviously, with isotopes, the number of protons in the nucleus will be the same for both of them. Obviously, they're the same element. However, the number of neutrons in the nucleus is different between the isotopes. Nitrogen 14 has 7 neutrons in the nucleus, whereas nitrogen 15 has 8. Now, both of these statements are worth a mark each. If you used to make a relative statement about isotopes itself, that's be worth 1 mark. Excuse me. Now, given the electronic structure diagram of boron below, we asked to state how many protons and neutrons are present in the nucleus of the boron. So there are 5 protons and 6 neutrons in the nucleus, the most abundant isotope of boron. And you can tell this by what I use is looking at the number of electrons. As you know, it's just an atom, so there'll be no overall charge. It's not being ionized in any way. So look at the number of electrons in the shells. So there's going to be 5, and now obviously that's balanced. And you look at the nucleus itself. Just count maybe 5 protons, and obviously count the other particles in the nucleus. Then it'll be 6 neutrons. And how many electrons are in the outermost shell of boron? That's in group 3. As well as from the diagram itself, you can clearly see there are 3 electrons in the outermost shell. Now, this one, you're asked to write the letters A, B, and C in the diagram applicable to these statements below. Now, A with the electronic structure of 2 electrons in the innermost shell and 4 in the outermost. Obviously, that is related to this position here, which would be period 2, group 4, which would be carbon. B, the element in group 2 in period 4, so group 2, be in this group here, period 4, 1, 2, 3, and 4, fit here. Then C, an element that shows both metallic and non-metallic. Now, these are your metalloids. Now, obviously, you've got boron, you've got silicon, germanium, you've got across arsenic. Now, all of these answers would be accepted, but for the sake of simplicity, sticking to boron, silicon, germanium would be easier. Now, given the table here, you are shown the reactivity of halogens with iron wool. Now, fluorine itself will explode in cold in the dark, whereas chlorine explodes in sunlight, and bromine is a small explosion with an ignited flame. We have to ask to explain why the halogens react in a similar way and why they react more slowly going down the group. Well, the halogens will react all by gaining an electron in the outermost shell, as they all have 7 electrons, as they are group 7 elements. And they want to gain that electron to become more stable. But the reactivity will decrease down the group, as obviously as the atoms get bigger, the outermost shell of electrons is further away from the nucleus, and so will feel less of a pull from the nucleus itself, and so the other electrons will be pulled less strongly, and therefore will be less reactive. Now, for this question, with hydrogen fluoride being highly corrosive and used to etch glass, we're asked to simply balance the simple equation for the reaction between hydrogen fluoride and silicon dioxide. Obviously, to balance the number of oxygens on both sides, you have a 2 in front of the water molecules to have 2 oxygens balanced. And then simply to balance both the hydrogens and fluoride ions or fluorine on both sides, you have a 4 in front of the hydrofluoric acid. Hope that makes sense to people. Now for isotope question here, to calculate the relative atomic mass of lithium, you are given the percentage present in the sample of lithium-6 and lithium-7. And to calculate the overall atomic mass, you simply use the equation of isotope 1 mass times its abundance plus the isotope 2 mass times that abundance, all divided by 100, and you should be getting 6.92. Now, for this question, you are given the relative stabilities of the group 2 carbonates and nitrates, and you've awarded 1 mark for each for any 2 correct statements. For example, stating that both carbonates and nitrates become more stable down the group is correct, and nitrates are more stable than carbonates. Stating both those statements would lead you 1 mark. And saying that range of stability is less for carbonates than nitrates, and that magnesium nitrate is far less stable than the other nitrates, would also lead to having 1 mark. Potentially stating that the calcium nitrate and strontium nitrate are similar in stabilities, also have similar nitrate stabilities, would also lead to getting a mark. When carbonate decomposes, it produces carbon dioxide gas. You have to describe an experiment that could be carried out to show that carbon dioxide gas is produced during the reaction. Now, heating in boiling tube with delivery tube, obviously heating the carbonate with a boiling tube and delivery tube to connect it up and to be able to bubble it through lime water to show that carbon dioxide obviously be given off when it decomposes, and to confirm the presence of CO2 gas when bubbled through lime water, that the lime water itself will turn milky. Now also, when calcium nitrate decomposes, you're asked to write the simple equation for the reaction when calcium oxide, oxygen, and nitrogen dioxide are formed. Now calcium nitrate, obviously shown below in CaNO3 will form calcium oxide, CaO, plus oxygen, obviously O2, and nitrogen dioxide, NO2. Now simply to balance this equation, obviously you have oxygen dioxide, or just oxygen gas, with calcium dioxide and nitrogen dioxide. There are a lot of oxygen atoms, obviously, so you have to be very careful. So when you first doing the drawing structure, I would recommend drawing out fully the reactants of the calcium nitrate, as that would get you about 6 of your oxygens as well as 2 of your nitrogens. And then you simply just want to continue this balance with everything until you have your oxygens here with just fully balanced. Now you get 1 mark for having the reactants correct, 1 mark for the products correct, and 1 mark for being fully balanced. Now using the letters A to D to complete the following sentences, 2 atoms that are in the same group are obviously A and D, as they have 3 electrons in the outermost shells. The atom found in group 1 is C, as it has 1 electron in the outermost shell. Now give the electronic structure of atom B. That'll be 2, 8, obviously 2 electrons in the inner shell, and full outer shell of electrons, obviously 8 electrons, so it's 2, 8. And give the atomic number of atom B, that would just be 10. That's obviously 10 electrons. The atom itself would be overall no charge, ionized, and if you have 10 electrons, you would have 10 protons, and the atomic number is the number of protons in the nucleus of the atom. Now particle X is an electron, and particle Y is found in the nucleus and is a neutron. Now using the diagram, explain why lithium has a mass number of 7. Well, you can either state that there are 7 particles in the nucleus, or if you want to be more detailed, state that there are 3 protons and 4 neutrons in the nucleus, as you can count obviously here, and obviously knowing the fact that there are either 3 protons in lithium, in the nucleus of lithium, or by working out using the electronic structure. So obviously the atom has to have no overall charge, it's not ionized, and so if there's 3 electrons in the shells, then there must be 3 protons in the nucleus to balance the charge. Now, to describe the trend in the melting point going down group 4, obviously decreases going down the group. Now the name element which has the greatest difference between its melting point and boiling point, again just look at the graph, be fairly obvious. That's obviously the large difference is with tin. And name an element of group 4 that is a semi-metal / metalloid. Now there are 2 correct answers to this, either silicon or germanium. Will do just fine. Now tick the box that describes where semi-metals are found in the periodic table. Well, simply they are all found between metals and non-metals. That is, and they obviously share characteristics of both metals and non-metals. And that is just a very simple question. I would say ready for that one. Here, obviously, given the table of the predicted properties of eka silicon and the actual properties of germanium, and you are going to fill in the table, which describes both the Mendeleev table and the table now, as well as both tables. Now the table is organized into group that is applicable for both tables. Mendeleev was doing this a while ago, as well as the current table is arranged in groups. Mendeleev's table, copper and potassium are arranged in the same group. However, as we know, in the current periodic table, copper is a transition metal. We don't really know that just yet. And potassium is obviously a group 1 element. In the Mendeleev table, there are gaps in the table, obviously left for elements to fill, or predicted elements. Obviously tables now that we don't have that, as we know that there's a structure to it, and we know that the increasing number of atomic number and number of protons going across, as well as similar properties going down the groups. And fluorine and chlorine are in the same group. Mendeleev did not have this, but in our, Mendeleev did have this, as well as our table also showed this as well. Apologize for making any mistakes, I'm a bit tired currently. Now tick the 2 statements that best describe why germanium was confirmed to be the element eka silicon predicted by Mendeleev. Simply, germanium has a similar density to that predicted for eka silicon, and germanium oxide has the same ratio of atoms that's predicted for eka silicon oxide. I'm going to go back and just show you that table again quickly. You can see here, density, very similar, and formula for oxides, and same. You can look at the formula of chlorides also, same. Now, to calculate the percentage of oxygen present in the formula of germanium oxide, obviously you know the atomic mass of germanium, which is 73, and the atomic mass of oxygen, which is 16. And simply, 16 times 2 for 2 atoms of oxygen, which would be 32. And you know that the overall mass of your germanium oxide will be 105. And simply just do 32 over 105 times by 100, and that'd be 30.5% or 30.48%. both will leave you full marks. If you only show that the overall relative mass of your molecule is 105, you'll get 1 mark. Now, potassium has 3 stable isotopes, 39 potassium, 40 potassium, and 41 potassium. Now compare the nuclei of each of these isotopes now. You are awarded 1 mark for any of the following. They all have 19 protons, but 20, 21, and 22 neutrons respectively. They all have 19 protons, but different number of neutrons, or all have the same number of protons, but 20, 21, and 22 neutrons respectively. Now, to calculate the overall atomic ratio of this of potassium, use the equation of mass times the percentage of isotope 1 plus the mass times the percentage of isotope 2, and so on and so forth. Obviously, that would be 39 times 93.1, 40 times 122, sorry, and 41 times 6.88, all divided by 100. And the 3 sig fig, that would be 39.1, and always assume 3 sig fig. That is a fairly safe bet. Unless stated otherwise, assume 3 sig fig. However, if you do 39.136468, sorry, you still get 2 marks. And if you just do the correct substitution without actually getting the final answer, you'll get 1 mark. Now, 2 similarities and 2 differences between the reactions of potassium and lithium with water. Now, for any two similarities, you get 1 mark. Obviously, they both float, they both move on the surface, both a bubble on the surface, and they both produce hydrogen gas, and they both form hydroxides / alkaline solutions when they come into contact with water. Obviously, one key difference is that potassium would melt into a ball, lithium won't. Potassium would ignite and burn, but lithium wouldn't. Potassium bubbles and moves more rapidly. Potassium is more reactive. And you should know that obviously going down group 1 elements, the elements become more reactive. And so from that, you should be able to understand that potassium will be far more vigorous, more aggressive when reacting with water than with lithium. And lithium will be reacting with water. Now, writing a balanced symbol equation for the reaction between potassium and water. You have simply potassium and water go into potassium hydroxide and giving off hydrogen gas. Obviously, 1 mark for the reactants, 1 mark for the products, and 1 mark for balancing both the reactants and products to get full marks.